Welcome to MyProjectBazaar.com. Now we discuss about the product for algorithm and architecture for a low power content addressable memory based on sparse clustered network. Next we see the abstract for the product. A content addressable memory is a type of memory that can be accessed using an contents rather than an explicit address. In order to access a particular entry in such memories, a search data word is compared against previously stored entries in parallel to find a match. Each stored entry is associated with a tag that is used in a comparison process. When a search data word is applied to the input of a CAM, the matching data word is retrieved within a single clock cycle if it is exit. The prominent feature makes CAM a promising candidate for applications where frequent and fast lookup operations are required. We propose a low power content addressable memory employing a new algorithm for associative between the input tag and corresponding address of the output data. The proposed architecture is based on recently developed sparse clustered network using a binary connection that average eliminates most of the parallel comparison performed during a search. Therefore, a dynamic energy consumption of a proposed designs is significantly lowered compared with that of a conventional low power CAM designs. Given an input tag, the proposed architecture computes few possibilities for the location of matched tag and perform the comparison of them locate single valid match. The CMOS technology was used in simulation process. Our process was developed in Tanner 13.0 software. The CAM process to reduce the overall area compared with MX conventional NAND architecture. Next we see the flow diagram for the product. First of all, the input bit data are opposed to the SRAM data register memory. This memory consists of 6 transistor based overall architecture. The SRAM data register to store the 1x4 bit data bits for overall architecturing process. Then go to the CAM array cell group. This array cell consists the 4x4 number of CAM cell for each and every bit storage process. This process to be based on bit and selection line input. This CAM cell, every CAM cell designs a 8 transistor based CAM cell architecture. Then go to the read and writing content for every controlling signal based on the selection process. Then go to the scan based match line sense amplification function. This match line sense amplification function is used to select the required data register based input and to apply the CAM cell every register element. This register element to check the SRAM data register address and the CAM address. Then to save the CAM address content to retrieve the overall data bits for our required CAM cell architecture. These CAM conditions to be identify the CAM data address bits and the RAM data address bit to be equalized or not. Then to equalize, then go to the clock based function and matching line enabling detection results. This enabling function to be controlled a clocking sequence for applied the overall architecture. Then to analyze the clocking sequence based match line detection. If the match line is correct, then go to the performance analysis. This performance analysis to identify the power and overall circuit processing. If it is not, then go to the another register selection line process for overall architecture results. This is our process overall flow process for CAM cell array designs and the input data register for match line selection process. This is our overall flow diagram for CAM cell based on sparse clustered network. Next we see the final output design for the product. Our output design is mainly based on CAM cell array of 4x4 array logic, then go to design C, RAM designs. Then to compare the RAM processing, first we design a single CAM array cell for single bit cell array device. Then go to the single bit SRAM design. Then to create the 4x4 CAM cell array based on single bit storage logic. Then go to the SRAM data register for each and every 1x4 data register. Then final design. This final design to given the input data for data bit register and to create the 4x4 array cell design. Then the data bit register to compare with each and every row processing used in match line sense amplification process. This amplification process which line to be equal for overall CAM cell array. Then to get the content, first of all main focus for match line detection process. This is our overall design for CAM cell memory storage for efficient content retrieving process. This is our design output results. This output results to be identify the which row is set the match line process. Another rows to be non-match line conditions. The match line conditions to be get the 5 volt and another process is to be 0 positions. This is our the row 1 process, this is our row 2 process, this is our row 3, then the row 4. Our SRAM data register to be match line for only row 3. Then the another signals to be 0 positions. Or which process to be equal, this is our the example correct output match line direction for overall simulation window. This is our the overall simulation final output results for match line direction. Whatever the row is equal, this row to be 1, another rows to be initially 0. This is our the overall CAM cell identification process flow.